All right, here's a project example. Again, I've changed the numbers here, so don't just write my answer down, but use this as a sample of how to follow and do your project. It says the legs of a right triangle, so I'm going to go ahead and draw myself a right triangle. That always helps. Measure 2x and 18. So remember, the legs are the two sides touching the right angle. The hypotenuse measures 2x plus 2. So over here on my hypotenuse, it's 2x plus 2. What is the value of x? Well, we have the sides of a right triangle, so we know we can use the Pythagorean theorem. A squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. My legs are 2x and 18. My hypotenuse is 2x plus 2. If I square these, 2 squared is 4, and x squared is just x squared. 18 squared is 324. And again over here I need to remind myself of what 2x plus 2 squared means. It means 2x plus 2 times itself, and we have to multiply that out one at a time. That's also called FOILing. Okay, so what we're doing is taking 2x times everything in this set of parentheses. So 2x times 2x is 4x squared, and then 2x times 2 is 4x. Then we take the 2 times everything. 2x times 2 is 4x, and 2 times 2 is 4. So we have 4x plus 324 equals 4x squared plus 4x plus 4x plus 4. Let's simplify this side. We can combine those two x's. Oops, I've been forgetting my squared over here on this side. That's not good. Okay, we have 4x squared plus 324 equals 4x squared plus 8x plus 4. And we want to solve. So let's gather the x squareds together. Here I had a positive 4x squared, so to move that to the other side, I would subtract 4x squared, do the same on the other side, and look at that. They actually just end up canceling each other, and there are no more x squareds in my problem. I get 324 equals 8x plus 4. I want to solve for x, so I would subtract 4 from both sides. That gives me that 8x equals 320. And finally, I would divide both sides by 8. And I get an answer of 40. So it didn't ask for side length, it just asked for x, so I am done. The answer is that x in this problem would be 40. All right, a cube has edges length 8 inches. So all of these edges here are at 8 inches. Again, I've changed that from your original question, so make sure you work carefully. Don't just write down my answer. What is the approximate length of the diagonal D? Now they've labeled it, goes from corner to corner in this cube. Well, we could use the Pythagorean theorem to find the length of D. We know this side is length 8, and notice we can form a right triangle if we go diagonally across the bottom here. That would form a right triangle, and we could use the Pythagorean theorem. The problem is we don't know this length either. So we're actually going to have to do this in 2 steps. We're going to have to find, I'll call this x down here, the length of this diagonal of the base, and then use that to find the diagonal D that they're looking for. So if I redraw that triangle down here, I have sides length 8 and 8, and I have x here. Right? We could use the Pythagorean theorem here. A squared plus b squared equals c squared. A and b are my legs, which were 8 and 8. So I have 8 squared plus 8 squared equals my hypotenuse of x squared. 8 squared is 64, and 64. I add those together. I get 128. And all I have left now is get rid of the squared. To do that, you do the opposite, which is square root. It said approximate, so I can go ahead and use my calculator for that and do the square root of 128 is 11.31. Okay, so now I can redraw this triangle and look for my D. I have a leg 8, a leg 11.31, and I'm looking for that diagonal. So I'm going to draw that triangle here. Can I have 8, 11.31, and I'm trying to find this diagonal D. Again, I'm going to use the Pythagorean theorem. Okay, leg squared, one of my legs was 8, plus leg squared, the other leg was 11.31, equals the hypotenuse squared. My hypotenuse was D. 8 times 8 is 64. 11.31 squared is 127.9. Add those together, so 64 plus 127.9 is 191.9. And my final step is to take the square root of both sides to remove that squared. Right, and I get that D is 13.852. So the approximate length would be about 13.9. Okay, so this famous ancient figure demonstrates the Pythagorean theorem. What does the illustration show? Well, notice here we have our right triangle, okay? And remember the Pythagorean theorem compares the lengths of the legs to the length of the hypotenuse. Okay, well, if we look at this, they've attached these squares on here. So how many squares are here? 3 times 3 is 9. Here we have 4 times 4, or 16. Now, what is 3 times 3? That's the 3 squared, right? So 3 squared is 9, excuse me. 4 squared is 16. Okay, and what do we get here? 1, 2, 3, 4, 5. 5 times 5 is 25. So notice it's showing that the leg squared plus the leg squared equals the hypotenuse squared. It's doing that with a visual representation. It's doing it using area of a square. Okay. So I'm going to let you decide which of the multiple choice answers it is, but that's how it relates to the Pythagorean theorem.